This video is an exemplar for a bivariate analysis NCEA Level 3 91581. If you want to achieve at a higher level for this standard, I highly recommend that you go through this video first, get your report up to achievement level, then you can sit back and relax for a day if you got the time, and then watch video 2 of this series, which will go into how to achieve for merit and excellence on this report. Let's begin. You're going to need to open several tabs in your internet browser. One is at stats.govt.nz. Another is at jakeformaths.com. On this page, you'll go to the NZGrapher link. You'll need a couple of Google spreadsheets open, and it would help to have a blank document ready to go. Let's begin. Without a clear goal, there cannot be victory. This is Sun Tzu, the art of war. I will apply this strategy to our success with writing this report. I condensed the NZQA requirements for 91581 investigate bivariate measurement data. It comes down to a series of tasks. Step 1. Use the PPDAC inquiry cycle to investigate bivariate data. We'll go to our blank document and make a template. We need to make a purpose. Now, your purpose depends on your data set. You're making a bivariate analysis. So all you need to do is find your X and Y. X and Y should be continuous data, not in groups. And we'll go hunt some down. So the easiest thing to do by far would be to go to NZGrapher and choose one of the files here of the data sets provided, and all you need is 2 continuous variables. So that would be your X and Y. So for example, your X could be mother's age, and your Y could be birth weight of the child. Those 2 variables would become the X and Y of your bivariate analysis. There's a bunch of data sets that you can look at. Any data that's continuous, like a price, engine size, weight, all that is continuous data and can be used in this report. Groups, for example, car name or drivetrain, that is group type data, and you do not want to use that in your bivariate analysis. Go back to babies. Now, if you want to score higher on this report, I suggest you go to stats.govt.nz and scroll down to InfoShare, where there's a whole host of fantastic data that you can use to pull together some really interesting bivariate analysis for some pretty useful things that you might actually want to know about for New Zealand, and the extra effort to go here for your data would make a difference in the depth of what you can go with for your report. So just keep that in mind when you choose your data. So I'm going to go ahead and use InfoShare to get my data. If you're going to use data from NZGrapher, you can skip ahead and I'll show you how to use this program. So we're going to take a look at using InfoShare on stats.govt.nz for a bivariate analysis. I'm quite interested to see what sort of long-term data series are available. Alright, so I've decided on the bivariate comparison that I'm going to do. I went into the long-term data series, the second folder in the long-term data series. Here I'm going to go into the value of goods exported. We'll do all merchandise trade, and we'll select all the years. Select comma delimited.csv and hit go. So that's been downloaded. I'm going to open up one of my spreadsheets here and go ahead and open a file. That's it right here. I'm going to upload, click and drag the file. So there it is. We have data from 1841 and onwards. This is all merchandise trade. Now let's go and get our other variable. We do need two variables. We'll go back into InfoShare and be interested to take a look at tourism. I've gone ahead into the tourism folder here and opened up as well international travel and migration. Now to pair up a X and Y bivariate analysis in the way I'm doing it now, it's really important that right here where it says annual December for the value of goods exported, which was the first variable I chose, it's really important that whatever I choose over here is also annual December. Take a look at visitor arrival totals, annual December. We'll go from actual count, and we'll select all of these dates, and we're going to choose the CSV. That's going to download. Alright, in another empty spreadsheet we can open up via upload, drag the new file into the box, and there we have it. Visitor arrival totals, annual December, actual counts, and this is starting from 1922. Alright, so let's go back to our merchandise data, and it looks like we can only pull data from 1922, so let's match it up. So we'll get data from 1922. I'm going to highlight all these cells, copy all that, bring it into our arrivals, click right beside 1922 and beside actual counts, and we're just going to paste that information there. And this was total exports. Now you can see there's always information at the bottom, and we've got dollars here is the units for exports, and also we can keep track of that up here. Now let's take a look at the bottom of our data set here. This goes up until 2011. So what I'm going to do is clean up the bottom of the data here so that all I have is my data. What you also want to do is get rid of this row up here by right-clicking and deleting that row. That way your column headings, and we can actually title this here as year. This is exactly how you want your spreadsheet set up. Nice and clean, nothing attached to the top or bottom of your data set. Now we're ready to download this, and we're going to download it as a comma separated values CSV current sheet. If you ever lose track of your downloads, you can always hit that tab, show in your folder. There's the file right there. I'm going to rename that as visitors and exports, and copy this into a more sensible place. Great. Now that I know exactly where it is, I'm going to go into NZGrapher. Can choose File, and NZGrapher is only going to read CSV files, so you got to make sure you save it as a CSV file. Now we need to decide which one is the X variable and which one is the Y variable, and this is very, very important that you get this right. So we've done this, we've picked our X and Y, and we'll just make it really clear that the X variable is the explanatory variable and the Y variable is the response variable. And what we're really asking here is, do changes in X cause changes in Y? So we really need to be careful, think about how we choose our X and Y variables. Here we have total counts of visitors in New Zealand from 1922 to 2011 and total exports in New Zealand dollars. Now here I need to choose my X variable. Now what I'm going to do is I want to see, okay, do the number of visitors who travel to New Zealand every year, does that have an impact on the total exports? So my explanatory variable is actual counts, the people counted as visiting New Zealand, and I'm going to see if the number of visitors is impacting my total exports. There's my Y variable. The graph type I'm going to choose is a scatter graph. Right away we're going to have to give the graph its title. So let's start with the x-axis. Now the graph title is always Y versus X, so we're going total exports versus number of visitors, and that's from 1922 to 2011. Let's update the graph with the new titles. There we go. It's really important that you're gonna hit the regression line, feature. Now I'm gonna right click on the graph. I'm gonna copy the image, go into my word processor and go into my data and paste this. There we go. All right. Let's finish the purpose. Now that we've got our variables, we don't want to have X's and Y's in here. I'm going to leave them here because I think it sort of is really important for you to get your head around. The most important bit is this here, that the X variable is causing a change in the Y variable. We're not sure. That's the whole point. From 1922 to 2011 has the number of visitors to New Zealand had an effect on how much we export. This is a bivariate analysis that will explore whether or not this is a bivariate analysis that will explore if the number of visitors to New Zealand is related to the amount we export in New Zealand dollars. Make note here, X variable is number of visitors and the Y variable is the great. Now, what's this graph telling us? Well, it's telling us quite a bit. Now, make sure you have a question, and it is a really good idea to get this down and make sure you understand that we're looking to see if the x variable causes a change in the y variable. You got to make sure that your question makes sense, and you got to make sure that the explanatory variable is on the bottom here. Let's go ahead and work on our plan. Now, NCEA is not too fussy about even having a plan. I think it's a good courtesy both to the reader and to help you organize exactly what you're doing. It's pretty quick. So we're going to source the data from InfoShare. We're going to construct a scatter plot of the data and insert a trend line, which is also known as a regression line. We are going to get the equation of the regression line. We're also going to get the R value of the data, and that would be the correlation or strength of the relationship between the two variables. Now, if that seems tough, we've already done it. It's right here. There's the equation. Total exports equals 15,663 times the number of visitors plus negative 466,610,000. There's the R value. Okay, and number here, that's the number of entries. We have exactly 90 data entries in our data set, which is fantastic. And we're going to take a look at the rest of the plan. I'm just pointing out here to you that this might seem pretty crazy, but NZGrapher did all the work for you. So after we generate the graph, get the R value in the equation, we're going to do an analysis of the data, and then we're going to draw conclusions. So that's the plan done. Data is done. We're going to make a quick note here about the source of the information and also taking a look at any suspicious data. So basically, if I saw a data point out here, I'd be tempted to take it out. I'd really have to go into the data set and have a look and think about that piece of data, whether it's worthy or not. But as you can see, this data is looking pretty sweet. There's no outliers. So I'm not going to just ignore that. I'm going to make note of it just to show the reader that, yes, I'm thinking about the quality of the data. So upon visual inspection, there are no obvious outliers or data points of concern. I'll also note that InfoShare is a reliable source of information for these types of data. It's coming from the government, so I'm not sure if there's any other source of this data anyways. So we'll just say it's reliable, and we'll go with it. So let's start our analysis. We'll go back to our task sheet here. We've gotten as far as the analysis here. So we've done this. We've posed an appropriate relationship question. And now we're going to identify features in the data. there's exactly 4 different observations that you're expected to make, and the first 2 are about the relationship between the 2 variables. So we're going to have to talk about the strength of the relationship and the direction of the relationship. Let's start off with the direction of the relationship. So we'll have to go back to our graph, take a look, and clearly this is what's called a positive trend. We're going uphill here. The slope in the equation's positive. Okay, this is a positive trend. And if your slope was going down in this case, that would be called a negative trend. So if your slope is going down, then your report will differ quite extensively from certain analyses. If your line goes straight across and everything's looking really loosey-goosey with the data points, you could possibly say there's no slope and no trend. So let's go into the analysis and talk about the direction of the relationship. We're going to give a heading direction of the relationship between visitors and exports. I notice that as the number of visitors goes up, the exports also go up. This shows a positive relationship between the number of visitors to New Zealand and the amount we export in New Zealand dollars. Notice how I'm being quite clear about the context here. That is quite important. So we've talked about the direction of the relationship between the 2 variables. Let's go ahead and look at the strength of the 2 variables. We're going to give this a section heading as well. Strength of the relationship between visitors and exports. So now we're going to talk about the strength of the relationship. So what makes a strong relationship? What makes a weak relationship? There's 2 things we can talk about. One is the visual inspection, and we can see in general that these data points are pretty close to the line. This is a pretty tight data set, and that's something we can talk about. So you're either going to say the data points are pretty close to the line, or if the data points are scattered all over the place, you probably say that the data points are not close to the line, and that would tell you that that's a weak relationship. This right here is telling us that this is a strong relationship between how many people visit New Zealand and how many total exports we have in that same year. So upon visual inspection, I notice that the data points are all quite close to the regression line. Now remember that regression line is also known as a trend line. It's like the happy median of the data. Upon visual inspection, I notice that the data points are all quite close to the regression line. This indicates that there is a possibly a strong relationship between the number of visitors to New Zealand and the amount we export in New Zealand dollars. Again, I'm being very complete about the context. It's quite important. I will note also regarding the strength, that's where this R value comes in. Okay? In stats language, the strength of a relationship between two variables is often referred to as an R value. And let's talk about that R value right now. The R value, which is also called a correlation coefficient, represents the strength of the relationship between the number of visitors and the amount of exports. The correlation R value is in this case equal to 0.989. Now, to understand what this value means, I have a chart that you can link to below this video that puts it into language what's what with these values. So the values for R can be anywhere between -1 and +1, where +1 is a positive slope, which would represent perfect positive correlation or perfect strength between two variables. And we are at 0.98, which is pretty high. That's a strong positive correlation. So let's go ahead and mention that in our report. This represents a strong positive correlation between the number of visitors in New Zealand to New Zealand and the amount we export in New Zealand dollars. We can remind the reader that's between 1922 and 2011. We'll go back to our task sheet here, and this is done. We need to decide whether a linear model is appropriate. So in this case, we can take a look, and I'm going to say that yes, a linear model looks good. A line fits this data nicely. You could possibly get some sinusoidal curve that goes up on an angle, but that's well beyond what's expected. If anything, you might get a data set that curves up like this. What you can do is click on the options for the different equations and just see what looks best for your curve. Nothing's really looking as good as the line that I started with, so I'm going to say that yep, the line is going to be fine, and that will take care of this task of analyzing whether or not a linear model is appropriate. Let's go ahead and do that. And I'm going to have a section heading for that called linear model. The data appears to fit a linear model very well. The equation of this model is, and that was given to us from NZQA. That's this right here. Where total exports in dollars equals $15663 multiplied by the number of visitors, and that is then subtracting 466,610,000. We can also write this equation simply as y equals 15663x minus 466,610,000. All right, these two equations are exactly the same. That takes care of that aspect of the analysis. Now, we have to bring up this fourth idea of any clusters and unusual values. Now, we did discuss the fact that we didn't think there were any unusual values earlier, but let's go ahead and make a fourth observation about possible clusters or unusual features. And I can't help but notice that as we get more and more visitors, we sort of get a little bit sloppier out here. So it looks like from about, let's see what that axis is saying. Looks like from about 1.66 million visitors onwards, seems like the data points tend to scatter a little bit more. Things are a little bit crazier on this end. So I'm going to make note of that as my fourth observation. I'm going to go ahead and say I notice that the more visitors there are, the data seems to be more spread out. Specifically, after about 1.6 million visitors, you can see that the exports tend to become more scattered around the trend line. That's 4 identifying features. Before I move on, I'm going to go ahead and bold all my nice titles just as a courtesy to the reader. And going back to our task outline, we need to use the graph and an equation to make a prediction. Make a heading here, we'll call it predictions. I can certainly predict that the more visitors we can attract to this country, the more we're going to export. So let's predict that. First of all, from the graph, it seems likely that if New Zealand continues to attract more and more tourists, New Zealand will export more goods. Now, I use the graph to make a prediction, and I'm going to use the equation now to make a prediction. This might look a little bit confusing, but excuse me. This might look a little bit confusing, but you'll see I'll just pull up a very simple calculator to do this calculation. So what do we want to do a prediction for, really? And predicting is all about thinking about what's going to happen in the future. So we can say something like, well, hey, if we can get 3 million visitors to New Zealand, what sort of exports can we expect in that case? This is what the whole point is for doing this kind of analysis, is to predict the future. So let's pull out our crystal ball and make a calculation to see, based on this analysis, what sort of level of exports we can get if 3 million people come into the country as visitors. So I can make a note here. If 3 million people visit New Zealand, the equation y equals 15663. Actually, what I'm going to do is copy and paste this equation and be done with it. There we go. So the equation, and that's the equation right there, can be used to predict the amount of exports in New Zealand dollars we could expect. What do? We're going to take the number 3 million and put it into the equation. Now the easiest way to see it is that just goes in for x. The x variable is number of visitors. We're considering if 3 million people visit us, what would happen to y, which is the exports. So we'll use a calculator and we're going to go 15663 times the 3 million. And we need to subtract 466,610,000. And that equals $46.5 billion. $46.5 billion can be expected to be generated according to this model. Now the model is the equation, and the equation came from the data. So this is real data, and yes, we can expect, if we can pull 3 million people into the country, according to this analysis, we can expect we'll get $46.5 billion in exports. Can be expected to be exported Great, so we've made our prediction and we need to finish the project by making a conclusion. Now you need to remind the reader what the point was. So let's just copy and paste that under the conclusion heading. This analysis shows that the number of visitors and the amount New Zealand exports in New Zealand dollars is positively related. There is a strong relationship between these two variables. We are able to predict how much we may export based on how many people visit our country. And that is the project completed. So let's make sure about this. I've used the PPDEC cycle. I did pose an appropriate question. I did 4 identifying features. I did use the graph to make a prediction, and I've made a conclusion by answering the question. Now, zoom out a little bit here, and what you want to do is take a last look at the project. We're going to take this away now. Bold all your headings. It's going to look great. There we go. Bold predictions and conclusions. Now we're going to save this with an appropriate name, and again, as a service to the reader who is going to be marking you, good idea to make a sensible file name such as your name .91581.bivariate is possibly a sensible file name. Let's go with that. And you're good as gold to send that off. After you read over your work once, when you go back over and edit your report, it's absolutely crucial that you have the marking scheme provided by your instructor so you can check and make sure that you've done every criteria for Achieve. You should do this simply because every marking scheme might be slightly different. The way an instructor interprets what's required by NCEA might be slightly different from what I have done here on this video. So make sure as you edit, you check each individual criteria for achieving. Now you're ready to move on to shoot for merit or excellence. Learn how you can take this to the merit and excellence level. For this standard, you can watch part 2 of this video, and we'll take a look at the merit and then excellence levels in one video because they're very closely related in a lot of ways, and it just is easy to do both at once. So thanks for watching, and go for merit and watch the next video. Are you stumped? Maybe we can help. Book a Skype session right now, get tutored from your home over Skype, and reach your goals. No professional would ever submit without having a pro look at their work. With so much on the line, why would your work be any different? Go to highschoolexcellence.com to see how you can submit your reports for professional feedback and get the scores that you need to succeed.